Okay, here we go with our problem set for the lesson on scaling pattern blocks. This is really good information. I highly suggest that you read this. Okay, on the grid, we're going to draw a scaled copy of polygon Q using a scale factor of 2. Compare the perimeter and the area of the new polygon to those of the original. The instructions are there, and here is the shape. So I'm actually going to pause this, and when I draw it, I'm just going to do twice each component. Okay, so I took a moment and I just multiplied each length by 2 and recreated this figure using a scale factor of 2. Now I'm going to find the area of each one of these by counting the number of squares inside each shape. So I counted the number of boxes inside each figure, and I just put these little X's there to make sure I didn't count anything twice or miss anything. And what I see here is to go from the area of the original to the area of the scaled copy, that I've not just multiplied by 2, I know that is times 4. Or in other words, times 2 times 2. And the scale factor, remember, was 2. So for the area of the new shape, you take the original times the scale factor squared. All right, now the perimeter, let's see how that works out. We've not even looked at that yet. So let's just count around the edges of each shape and see what we come up with. So I did pause the video, and I found the perimeter of this shape by counting around the outer edge, and also this shape by counting around the outer edge. And what I discovered was I'm actually just multiplying by 2 when I use a scale factor of 2 for the perimeter. The perimeter of the second shape will be twice as large as the original. And if I think about it, it makes sense. Perimeter is a linear measurement. It's just one measurement, just a length, whereas area is measuring how many squares it would take to cover something, which a square actually has a length and a width. So we're talking about 2 dimensions versus 1. And that's why there's a difference there. The next question is asking about a right triangle, and the area of this triangle is 36 units squared. The areas of the scaled copy. So if I'm using a scale factor of 2, I would take the original area times the scale factor times the scale factor. Whatever the scale factor is, I'm going to do the scale factor times the scale factor, because area is a 2-dimensional measurement, which means it's going to end up being units squared because it's square units. So you take the original area times the scale factor squared. And you could even think of it like this, times the scale factor times the scale factor. Because the first time you use the scale factor, that accounts for the length. And the second time you use the scale factor, that accounts for the width. So, and at this point you could really you could use a calculator, or you could do some mental math, just whichever way you prefer to find the final results for these. So I went ahead and just worked all of these out. Notice that area is measured in units squared. So up here, it would be a good idea to put units squared for my area. Whoops. And then for my perimeter, just put units. Just helps to distinguish between the two. So number 3, I didn't require you to do that in the lesson, but Diego has drawn the scale copy. So polygon, I'm going to go ahead and go over it. Polygon P, and then we have polygon Q. So P was the, that's a P, P was the original, and Q is the scaled copy. Now the area of polygon P is 72 units squared. So what scale factor did he use to go from P to Q? So the area of Q is 1, 2, 3, 4 and a half. That's what I would, close to 4 and a half. So I'm not really sure I'm okay with estimating that. Let's see. So I know I have these 3. Then I have 2 triangles. Let me just do the area of a triangle real quick. Area of a triangle is 1/2 base times height. So the height there is 2. The base is 1. Half of that. So half of 1 times 2. Half of 2 is 1. Okay. So at this point I have 1, 2, 3 squares plus 1. And this is, we'll just do another area of a triangle. 1/2 base times height. 1 and 1. 1/2 of 1 times 1 is 1/2. Okay, so it's exactly 4 and a half. I just wanted to make sure of the new area units squared. So this is 4 and a half units squared. Now, what factor did he use? So what I'm going to do, I'm going to take, this is obviously smaller. So he's used a scale factor that's less than 1. If you use a scale factor of 1, you would get exactly the same. If you use a scale factor of 2, then you would get a larger new shape. But he's got a smaller new shape. So thinking about that, I'm going to come up with a number less than 1. So I'm going to do the new area divided by, the original area, which I was given here. So 4 and a half divided by 72. All right, that's 1/16. Now, what number times itself gives you 1/16? Because if you remember, you take the original area times the scale factor times the scale factor. So the scale factor would have to be a number times itself that gives you 1/16. I think it's 1/4. Let's double check. 1/4 times 1/4. Let's look at that as a fraction, 1/16. And if I'm correct that 1/4 is the scale factor, then I can take the original area times the scale factor, times the scale factor, and get 4 and a half, which is my new area. So that was correct. Let's make sure we had this written down. Now again, this one was optional. I felt it was a little much. So the scale factor is, it's actually the square root of 1/16, which is 1/4. Now, I'll write that over here. The scale factor is 1/4. Again, that was optional. So for these last 4, if I can really just look here from 2 to 1, the scale factor from the original to A, the scale factor looks like it's half. 1, 2, 3, 4, that's doubled. 1, 2, 3, I'm just looking at the length. 1, 2, 3. Okay, so that's C. That's 3/2. 1, 2. And that's exactly the same. So that's a scale factor of 1. All right, and that is it for that lesson. Thank you.